Okay, now we're going to start with question number 12a here. We're at 10 to the power of 3 log x plus 2 log y. We need to get this simplified fully. So one thing we need to do first is we need to get those those coefficients out in front back inside the log so we can cancel some things out. So using our rule, we know that coefficient out front is equal to, it'd be on the inside, so we can write log x to the power of 3 plus log y to the power of 2. Now that we have an addition with logs with the same base, we can say that the things on the inside are being multiplied. So we can say 10 to the power of log x3 y squared. And since this is assumed log base 10, because it doesn't have anything as log base 10, 10 to the power of log 10, those are going to end up going away. And now we're just left with x cubed times y squared. Now we're going to look at question B. We're given e to the power of natural log the square root of x minus 5 natural log of x. So just like the last one, what we want to do is we want to get rid of that 5 coefficient out front and bring it to the power of x on the inside. And we're also going to rewrite this square root of x in terms of a power. So we're going to say e to the power of natural log square root of x. Another way to write it is x to the 1/2, and then minus natural log of x to the 5th. Now, based off our log rules, we know that if we're having two logs being subtracted, we know that's the same as what's inside being divided, right? So we can say e to the natural log of x to the 1/2 over x to the 5th. So next thing we see is that e and natural log, those have the same base, and they're inverses, so we can cancel them out, and we're left with x to the 1/2 over x to the 5th. So we want to rewrite this x to the 5th is x to the 1/2 times x to the -5, and multiply those together so we can add those powers together. So when we multiply anything with the same exponent, it's like we're adding our exponents together. So now we're saying that x to the 1/2 minus 5, and we're going to write this as x to the power of -9 over 2. And that's the simplest that we can go with this equation.
Okay, doing number 13, it says the graph of y equals log base 4 of x is shown. Let f of x equal negative log of 4 x plus 2. What is the domain and range of the function? Use interval notation. So let's first graph this function. So we know that this is our typical asymptote right here, right? And we are going to graph this new function. So it says step 1 is we are going to reflect it over the x-axis. So that would kind of look something like this, and it's passing through that point 1. Okay, and that vertical asymptote would be right here, where it typically is, right? But it's asking us to, we also need to shift this, right? So we need to shift it to the left 2. So we're going to move this point right here, which is a good point we have. We're going to move it 1, 2, and then our new graph is going to look something like this, right? Okay, so that's our new graph, and then our horizontal asymptote would be over 2. So this was our original horizontal asymptote, or vertical asymptote, and we're going to move it over 1, 2. This is our new vertical asymptote. Okay, that's just from the graph, right? Pretend that goes through that point there. Okay. And so it's asking us for the domain and range. So our domain, remember, is our x values. So our furthest left value is going to be -2. But we cannot include -2 because that's our asymptote. So then we're going to put a parentheses. In this graph, we can see it's going to all the way to infinity to the right. So that's our domain. Okay, and then our range is going to be up and down. So we can see this goes from negative infinity all the way to positive infinity. So negative infinity to positive infinity for our range. Okay, so fill in the blanks. As x approaches -2 from the right, where does f go? Okay, so as x is going to -2 from the right, f of x is shooting all the way up here towards infinity, right? So we can say this one's going to positive infinity. Okay, and then as x approaches infinity, where does f of x approach? So as we're going to the right as far as we can go, we can see that this graph is going to go down indefinitely. So we're going to say negative infinity. Great. And then our vertical asymptote. So remember, we're shifting our asymptote, so we shifted it to the left. So 1, 2. So our vertical asymptote is going to be -2. All right, number 14, asking us to solve these equations for x. So we have 10 times 2x to the plus 5 equals e to the 7x. So first we're going to take the log of each side so that this 10 cancels out. So these cancel, and so we're going to have 2x plus 5 equals log e of 7x. Our log rules tell us we can drop this down, so we have 2x plus 5 is equal to 7x times the log of e. Okay, so then we can subtract 2x from both sides. We have 5 equals 7x log e minus 2x. Then we can factor out this x, log of e minus 2. And then we can divide by this whole 7 log e minus 2. So then x is equal to 5 over 7 log e minus 2. And then if we put that into our calculator, it's approximately 4.81. Okay, so this next one is log base 2 of x plus log base 2 of x minus 7 equals 3. So our log rules tell us if we have two logs with the same base added together, we're going to multiply the insides. So we can say log base 2 of x squared minus 7x is equal to 3. I can take both of these to the power. I can take the power of 2 to both of these. So 2 to the power of this, 2 to the power of that. These are going to cancel. We get x squared minus 7x is equal to 8. And then we can see that this is going to be a quadratic. And so we have x squared minus 7x minus 8 is equal to 0. Factoring this out, again, two numbers that are going to multiply to -8, add to -7. That's going to be x plus 1. X minus 8 equals 0. Solving these, we get x is equal to -1, and x is equal to 8. But now we need to think about this in our bounds. So x is equal to -1. Well, that would mean that we would be able to plug in a -1 into this original equation here, and that would give us a negative in our log, which can't happen. Remember that? So it can't be -1, so this value is not going to work for us. That means x equals 8 is our only answer. Okay, so part A is asking us, during one of the regular visits, scientists counted 250 turtles after how many years had passed since the initial turtle count? Okay, so we are going to put 250 into this equation, or set it equal to this equation, really. E to the 0.045 t. Now we're going to solve for t. So we're going to divide by 175. And then we're going to have 250 over 175, e to the 0.045 t. We take the natural log of both sides to cancel out that e. And so these are going to cancel. So we get the natural log of 250 over 175 equals 0.045 t. Then we're going to divide by 0.045. Then we're going to put this part in our calculator. And once we do that, we're going to get t is equal to about 7.926 years. So it's asking, assuming the populations of turtles continues to grow at the same rate, by what percentage should the population increase in a decade, 10 years? Round your percentage to 2 decimal places. So what we're going to do is we're going to have our e to the 0.045 times 10, and we know that's going to be approximately 1.5683, and if we subtract off this 1, we're going to get 0.5683. Changing that into a decimal, we're going to get 56.83%. Okay, so it is asking us to find a quadratic formula for this tennis ball thing. So let's draw it first to get kind of a sense of what's going on. So if we have our graph here, it says a tennis ball is shot upward from a height of 6 feet above the ground. Okay, so we're about 6. Well, that makes it look like a negative. Not what I wanted. 6. And then it says it was shot vertically upward at a height of 6 feet. At the time 3 seconds, it was at its highest point. Okay, so 3, somewhere up here. And its highest point was at 177 feet. So maybe our graph looks something like this. Okay, awesome. And this is our peak right here at 3,177. Awesome. So it's asking us to find a function. And so if we remember our vertex form, we have f of t is equal to a times t minus h squared plus k, where h and k is our vertex. So this is going to be equal to a t minus 3 squared plus 177. Okay, so this is our f of t. We also have one other point here. We know it's at 0, 6 is another point we have on the graph. So if we use that, we can find out what a is. So if we plug in 6 for f of t, it's equal to a times 0, 3 squared plus 177. We end up getting, if we put that into our calculator and solve, we end up getting a is equal to negative 19. Okay, so then our vertex, or this formula for this graph, is going to be negative 19 times t minus 3 squared plus 177. Okay, so now it's asking us what was the height of the ball at 5 seconds. So what we're going to do is plug in 5 into that formula. And we're going to say, so f of 5 is equal to negative 19 times 5 minus 3 squared plus 177. Plugging that into our calculator, it's going to be equal to 101. So that means the height at time 5 is equal to 101 feet. Okay, so number 17 is asking us to find the leading term. So we're going to pick out those terms that are going to give us the highest power of x. So we have 5 times 4x to the 5th. And then we're also going to multiply this by 3x squared. So what's going to happen is that's going to give us a negative 5 times 1,024 times x to the 5th times 9x squared. If we simplify that out, we're going to end up getting negative 46,080 x to the 7th. So this is going to be our leading term here. And then our degree is going to be this power here. So that's going to be degree 7. Okay, so finding our zeros in their multiplicity, right? So it's when this function is going to be equal to 0. So that's when these insides are going to be equal to 0. So 4x minus 3, set that equal to 0. We end up getting, we add 3 to both sides. 4x equals 3 divided by 4. X equals 3 over 4, right? And that 0, we can see it has the 5 power there. So it means it's going to have a multiplicity of 5. And so our other one is 3x plus 1. We set that equal to 0. Subtract by 1. Divided by 3. X is equal to negative 1/3. And we see that one has the power 2. So it's going to have multiplicity 2. Okay, so it's asking us kind of some endpoints of this. And so we know that this is an odd function because of the degree, and the leading coefficient is negative. So that means our graph is going to be pointing up at negative infinity and pointing down at positive infinity. Okay, so then it's asking us, as x goes to negative infinity, f of x goes to what? It's going to be positive infinity. And then it's asking us, as x goes to infinity, f of x goes where? That one's going to go down to negative infinity. Okay, so it's asking us to evaluate these limits. So we have the limit as x grows infinitely large of 3x squared minus x plus 1 over 2x squared plus 5. So if we think about this, like if we think about as x is getting infinitely large, if we think about plugging in like a super big number in for x, this plus 1 and this negative x and this positive 5 aren't really going to affect these numbers too much, right? Because they're going to be so small in comparison to like if we were to plug a million in. So then we can rewrite this thinking about the limit of this x goes to infinity of 3x squared over 2x squared. And as this gets larger and larger and larger, these x squares are really just going to cancel out. So then we can say the limit is going to be equal to just 3 over 2. Okay, so evaluating this next limit, the limit as x approaches negative infinity of 8x to the negative 3 plus 5x to the negative 1 plus 1. We can rewrite this as 8 over x cubed plus 5 over x plus 1. And think even as this x gets infinitely large, even negatively infinitely large, that these are both going to go to 0 because any value over a super small value is going to, or a super large value, is going to end up being super small. Like 1 over a million is tiny, right? So both of these are going to go to 0, right? And so we're going to be left with just 1. So the limit as x approaches negative infinity is going to be equal to 1. Okay, so our first step for this problem is we're going to simplify this rational function. So we're going to factor out the bottom. So we have 3x plus 8 times x minus 1 over that factored is going to be x minus 2 and x plus 8. So we can cancel these out for simplicity purposes. And we're going to have x minus 2. Okay, so let's do our vertical asymptote first. So a vertical asymptote is when we have like a 0 or something in the denominator where that's going to give us an issue. So we say x minus 2, we set that equal to 0. If we add 2 to both sides, we get x is equal to 2, and that's going to be our vertical asymptote. Our horizontal asymptote, however, is going to come from our coefficients. So if we're going to take our thing with the highest power, which is going to be this 3. So we have 3x over x, right? Those are the highest power, so those are going to cancel, and this is end up going to be 3 for our horizontal asymptote. So at y equals 3. So let's plot those on our graph. So our vertical asymptote at x equals 2, and then our horizontal asymptote at y equals 3. So now I know our graph is going to look something like this. Right? Okay, so it's asking us to determine whether there are any holes in the graph. If so, give the coordinates. So we do have a hole in our graph, and it's going to come from this x plus 8 that we ended up canceling out. It does cancel out, but it is still there, and we need to account for it. So that means that at negative 8, when that would be 0, we have a little tiny hole right here at negative 8. So yes, it's going to be at negative 8, and then so we're going to need to plug in negative 8 into this formula here to make sure to find those coordinates. So we have 3 times negative 8 minus 1 over negative 8 minus 2, and that's going to simplify down to negative 27 over 10, over negative 10, sorry. So then that's going to end up being 2.7. So then we have a whole yes, and the coordinates are negative 8, 2.7. So now it's asking us for our domain and interval notation, and so remember, this function is going to be all set and all dandy except for our hole and our horizontal asymptote. So our hole is at negative 8, or not horizontal, our vertical asymptote, sorry, and our vertical asymptote is at 2. So then our domain is going to go from negative infinity to negative 8, union negative 8 to 2, union 2 to infinity. And then it's asking us to make a rough sketch of our graph, which we've already done. Okay, so it's asking us to find two angles that are coterminal with negative 9 pi over 7. One of those angles being between 0 and 2 pi. Okay, so remember, angles that are coterminal are angles that are on the same spot on the unit circle. So we're just going to add 2 pi to this and see where it gets us. So if we add 2 pi, that's going to end up being 5 pi over 7, which is sitting somewhere around here. Okay, and then so that one is between 0 and 2 pi, so that one's one of them. It's asking us to add another one, so we're just going to add 2 pi to that. So adding 2 pi to 5 pi over 7, we end up getting 19 pi over 7, which is also at that same angle, right? Okay, so those are our two angles, 5 pi over 7 and 19 pi over 7. Okay, and then it's asking us to find the quadrant and reference angle. So we just found the quadrant, right? It's going to be here in quadrant 2, Q2. And then our reference angle, remember, is how far it is from our x-axis. So if this is 5 pi over 7, then what's going to get us to a whole pi is going to be 2 pi. So it's going to be 2 pi over 7 is our reference angle. So this next one is asking us to find two different angles that lie in quadrant 2 that have a reference angle of 3 pi over 13. Okay, so if something that lies in quadrant 2, so somewhere over here, has a reference angle of 3 pi over 13, that means this angle right here is 3 pi over 13. Okay, so we want to figure out this angle, theta. Okay, well, we know that 3 pi over 13 plus theta is going to be equal to pi. So that means we need to figure out what theta is going to be. So we can say that 13 pi over 13, which is just equal to pi, minus 3 pi over 13 is going to be equal to that angle theta. So then theta is going to be equal to 10 pi over 13. So that's our first referencing, or that's our first angle that has that reference angle. And then we can just add 2 pi to this. So if we add 2 pi to this, we're going to be getting, it would be 10 pi over 13 plus 26 pi over 13, which is equal to 36 pi over 13, which would be a second reference angle. 36 pi over 13. Okay, so it's asking us if t is an acute angle such that sine of t is equal to x over 5 plus x for a positive number x. Find the values of each cosine t and tan t in terms of x. So let's draw this first. We're going to draw a little graph here. So it's saying our angle is sine of t, which equals x over 5 plus x for a positive number x. So that means our line is going to be sitting in this quadrant here. And then we can draw a little triangle down, and we know that sine is opposite over adjacent, so it's going to be x, and then this side is going to be 5 plus x. And we can label this side just a. We just don't know it yet. Okay, so we can actually figure out what a is because of Pythagorean theorem. So we can say a squared plus x squared equals 5 plus x squared, right? And then we simplify this out, and we get And this is going to be x squared plus 10x plus 25 equals x squared, a squared. We subtract x squared, reading a squared equals 10x plus 25, and then a is equal to the square root of 10x plus 25, okay? So now we know that this side is the square root of 10x plus 25, and so now cosine is going to be adjacent over hypotenuse. So cosine of t, this is our angle t, is going to be adjacent, the square root of 10x plus 25 over the hypotenuse, so 5 plus x. Great. And then tangent is just going to be sine over cosine. So we could do a big fraction, or we can just multiply by the reciprocal. So sine is going to be, so tangent of t is equal to sine, which we said was x over 5 plus x, times the reciprocal of cosine, so 5 plus x over the square root of 10x plus 25. These are going to cancel, so this is equal to x over the square root of 10x plus 25. Okay, so we're trying to find x here. So we can look and see we have two right triangles. One with a base here, we can label this A, and then one with a big base here, we can label this B. So we're going to be able to use that to find x. So step one, let's find A. So if we use this angle 40, tangent of 40 degrees is going to be equal to 300 over A. So solving for A, we get A is equal to 300 over tangent of 40%, which is congruent to 357.526. And then let's solve for B. B, or tangent, of 28 degrees is equal to 300 over B. Solving for B, we end up getting 300 over tangent of 28 degrees, and this is equivalent, or approximately 564.479. If we subtract A from B, so B minus A is going to be X, which is going to give us approximately 207 feet. Okay, so it's asking us to choose a model for this graph with either a sine or cosine function. So we're going to pick cosine because it is a little bit easier to do cosine because it starts at a peak or a valley, and that's what cosine starts at. This is our graph. And so we won't have to do a left or right shift. If we were to choose sine, then we would have to do a left or right shift. But we're going to pick cosine, so we don't have to do that. So our shift is going to be 0. Okay, so it's asking us to find the amplitude, and we know that our amplitude is going to be the distance from our midline to a peak or a valley. And we know that this bottom part, it says that our low was 69, so this is going to be 69 here, and that up here, our high is going to be 103. So the difference between 69 and 103 is going to be 34. So half of that is going to be 17. So we know our amplitude is going to be 17. Okay, so our period is going to be like peak to peak, valley to valley. So our valley is going to be here. And then we can drop a line down right here. So we go valley to valley, it's 24. So our period is going to be 24. And then our midline is going to be this point, this line right here. How we figured that out is we're just going to add our amplitude, 17, to our low at 69. So 69 plus 17 is going to give us 86. Okay, so let's first write the function in terms of cosine. So our function for cosine is y equals a cosine of b times t minus h plus k. In this case, our a is going to be our amplitude, but we notice that our cosine graph is flipped upside down. It's reflected, so we need a negative 17 instead of a regular 17. So y equals negative 17 cosine. Our b is going to come from our period. Remember, our period is equal to 2 pi over b. So our period in this case is 24 equals 2 pi over b. So b is going to equal pi over 12. So we're going to throw that pi over 12 in here. And then we don't have a left or right phase shift, so it's 0, so we don't need to have a b, so times t. And then k is going to be how high we go, when our midline starts. So our midline is at 86, so we're going to bump this up to 86. Okay, so our equation for our sine graph is going to be y equals a sine of b times t minus h plus k. So everything's going to be the same for our sine graph, except we need to shift this over, right? So our sine graph really starts at our midline, where our midline hits our graph, right, the first time, which is going to be right in the middle of half our period. So a fourth of our period, so it's going to be at 6. So this graph is shifted 6 to the right. So we need to have 6 in for that spot. Everything else is going to be the same, except the sine graph is right side up. It's not upside down. It has not been reflected. So we just need a y equals our positive 17 sine. Our b is still the same. It's pi over 12. And then remember, we shifted our graph to the right. So t minus 6. And then we're still going to move this graph up by 86. So that's our sine equation.